Okay. In the previous slides and video, we talked about underdamped motion and overdamped motion. As you talked about it, overdamped motion means there's no oscillation, but like it's just stretching out and come back to the equilibrium position. Okay. But what about the critical damped motion? Basically, it is the case which is gamma square minus 4 mk equals 0 case. In other words, your gamma square is exactly equal to 4 mk. But actually, like critical, like let me tell you the conclusion first, okay? The critically damped motion is also non-oscillating motion, okay? But this is the critical point between the oscillating or non-oscillating, okay? So, okay, let me talk about like the detail of this, okay? Since your gamma square is equal to 4 mk, or in other words, there is no plus minus term. Okay, let me rewrite your general solution. They make much easier, okay? And not general solution, but like your the solution for characteristic equation. It was minus gamma over 2n plus and minus and square root of gamma squared minus 4 mk over 2m, right? And we are talking about this side is equal to 0. Then you have like a repeated solution, right? Okay. Then the general solution is um, 8 times e to the rt, and the second term must be b times t times e to the rt, right? And we can just like write this one as a plus bt times e to the rt, okay? Again, your r is negative. Like look at your r. Like as I told you, gamma and m is positive, so your r is negative, right? And since your r is negative, then ut goes to 0 as t goes to infinity. That's a really obvious thing, right? And now let's talk about same concept with overdamped motion, right? So we're gonna try to find the extremum points, right? To do so, like we have to find the critical value first, okay? For critical value, we need u prime, okay? And what is u prime? Okay, let's start from here, okay? That's exactly the product form, right? Then by the product rule, and first term prime, a plus b, t prime is b, times second term, which is e to the rt, plus first term times second term prime, which is r e to the rt, okay? Let me combine these two. Then that is equal to b plus a plus btr times e to the rt. To find critical number, we're going to set this guy equal to 0, but keep that in mind. Exponential function never be equal to 0, right? So the only case is here. This part can be equal to 0, but since this is just linear equation, we could have only one, at most one solution for this equation, okay? So what does that mean? There is only one local maximum or local minimum, okay? Let me state this one, okay? Since u prime is 0 for at most one value, which means ut can have at most one extremum, right? It's like, as I showed you before, like in a like, overdamped motion, your solution graph will be like something like this. Does it make sense? So which means there's no oscillation for this case too. I can see. Okay, that's it. In next slide, next video, we're gonna talk about some application problems, okay? Thank you.